In question number 1, you're asked which one needs to be a true statement. So we're looking for a supplementary angle relationship. Angle 1 and angle 4 are vertical angles, so they're actually congruent. So that's not going to be it. Number 2 is angle 1 and angle 8. So let's see. So angle 1 and angle 5 are corresponding angles, so they're congruent because we do have parallel lines cut by a transversal. And angle 5 and angle 8 are vertical angles, so they're congruent. So 1 and 8 would therefore be congruent by the transitive property, because if 1 is congruent to 5 and 5 is congruent to 8, then 1 has to be congruent to 8. So they're not supplementary, they are congruent. Number 3 says angle 3, this one right here, and angle 6. But guess what? These are alternate interior angles, so they're congruent since we have parallel lines. They are not supplementary. So that leaves us with answer choice 4, 2, and 5. So 2 and 6 are congruent because they're corresponding angles. And then we can see that 5 and 6 are supplementary. They form a linear pair. So if 2 is the same as 6 and 6 is supplementary to 5, then 2 has to be supplementary to 5. Let's read the givens and mark the information in our diagram. So we have that AD bisects angle BAC. If an angle is being bisected, it's being split into two smaller congruent angles. So the two equal parts of BAC are angle 1 and angle 2. So we have one congruent half and a second congruent half due to the bisector. I'm going to put that over here. An angle bisector splits an angle into congruent parts. And the conclusion we're trying to draw here is why angle 2 must be congruent to angle 3. So we did have another givens, and all the givens are important. So make sure that you do put them down. They're all there for a reason. Let me actually just use the same color because it's talking about angle 1 again, and we already have a mark on angle 1. Angle 1 is now congruent to angle 3, so I can put the same mark on 1 and 3 with the same color. And now we can clearly see that 2 does have to be congruent to 3. We just have to figure out why. So we had that angle 1 was congruent to angle 3 from the givens. We have that angle 1 is congruent to angle 2 from the angle bisector. Notice how both angle 3 and angle 2 are congruent to the same angle 1. So that means these have to be congruent to each other. If they're both congruent to the same third angle, they have to be congruent to each other. And that is the transitive property. Over here, Kelly was given that angle A is congruent to angle EDF. Kelly has already proven that AB that's the full side, so I'll just put a mark, is congruent to DE, that's the full side as well. And it's saying which information would not prove the triangle congruent. So ACDF and SAS, side angle side, side angle side, that would work. Let me reset. Let me get rid of that information from answer choice 1, and let me move on to 2. BC, EF. Oh, that's ASS. Or from the other way, SSA, which we know backwards is a bad word. We have found the answer choice. That's not SAS, that's SSA or AAS. If you try out the other one, so like for example, angle C and angle F, AAS, it works. And if you try out the last one, it should work as well. We have AB parallel to CD. And we're also told that angle ABC is congruent to angle CDA. What jumps out to me first is that the two smaller triangles here have a shared side due to the reflective property. And also, since we have parallel lines, we're going to think parallel lines cut by a transversal. And we have congruent alternate interior angles. So we have AAS, AAS. Over here in this question, we're told that AB is congruent to AC. If a triangle has two equal sides, the angles opposite those sides, so this angle and this angle, are congruent. So if there's an x plus 20 here, this one is also x plus 20. We can take them. We can add them up, and we can equal them to 180, because all three angles of any triangles always sum to 180. I added wrong. 20 plus 20 is 40. And if we divide by 5 on both sides, we should get 28 for our x value. Let's check out number 6. We're told that LO is congruent to MO. So in this triangle over here, we do have two equal sides. And triangle has two equal sides. The angles across from the sides are also congruent. So we have 55 degrees right over here as well. We need to find the measurement of this angle of angle N. These two angles are supplementary. The 55-degree angle and the angle right next to it, they form a linear pair. So that is 125. And now in this triangle over here, triangle MON, we have two angles. We just need to find the third one. So I'm going to add up 125 and 28, the two angles that we have. And that is 153. All three angles of any triangle add to 180. So I'm going to subtract 153 from 180. And I got 27 degrees for angle N. Now we're up to the fun page, the proofs over here. So let's take a look and let's try to fill in the blanks over here. So we have angle ABE congruent to angle CBE. And we have angle ADE, ADE right here, congruent to CDE right over here. And what we need to prove, so our goal is to prove that BDE, this line segment over here, is the perpendicular bisector of AC. So if you take a look, it looks like it could be the perpendicular bisector of AC if we prove that it is in fact splitting AC into two equal parts. And remember, we also spoke about how a perpendicular bisector, if something is the perpendicular bisector of an endpoint, any point along the perpendicular bisector will be equidistant from the endpoints. So we can also keep that in mind also. I don't know which way in this proof it's going to have us prove it, by proving that AE is congruent to EC, or by proving that points along the perpendicular bisector are equidistant from A and C. So let's see what happens because this is a fill in the blank proof. So the first one's easy. BD is congruent to itself, and that's by reflexive property. So that leads me to believe that maybe we're going to be proving these two triangles over here congruent because we already have an angle in each, and now we have a side. So we just need one more angle in order to have AAS or ASA. So let's see what we're going to do here. So then they tell us that BDA and ADE are supplementary angles. So here's BDA and ADE. So I definitely see that these two angles are supplementary. And they tell us that angle BDC and angle CDE are also supplementary. And I definitely see how these two angles are supplementary as well. And they wrote here that's because they form a linear pair. So now they want us to say that, make a statement due to the fact that supplements of congruent angles are congruent. So we want to say something's congruent because it says are congruent. So let's think about it here. These were congruent angles. We want to say that the angles that are supplementary to them have to be congruent to each other as well. And let's think about why this makes sense. Let's say that this angle was 70. That means this one has to be 70 because they're equal angles. That was given. Since this and this are supplementary, this would have to be 110. Since this and this are supplementary, this would also have to be 110. So if these two angles are both supplementary, the congruent angles, they have no choice but to be congruent because these are the same. So these are going to be the same value to make that 180 degrees. So that's all that it's saying. So for the statement, it just wants us to say that these two angles are going to be congruent to each other due to the fact that they're supplementary to the congruent angles. So that's angle BDA and angle BDC. So now back to what I was saying about these two triangles. Now we have angle side angle. So now we know that those two triangles are congruent, and that's provided to us. So from here, now that we've already proven two triangles congruent, now they're saying that AD is congruent to CD. Notice how AD and CD are corresponding sides of the two triangles that we've already proven congruent. They match up. And notice how AB and CB match up on the two triangles as well. They correspond. So this is CPCTC because we've already proven the triangle's congruent. And now we want to say that the corresponding sides of them are also congruent because the whole triangles are congruent. And now from here, they're concluding that BDE is the perpendicular bisector of AC. Let's think about why this might be true based on what we proved. And this is a fill in the blank proof, so nothing else is required. They're telling us we already did it, but we just have to figure out how we did it or why we did it in this case. So we didn't use the fact that AE and EC are congruent to each other. We didn't prove anything about AE or EC. And we didn't prove that there's right angles here. So we didn't prove perpendicular bisector because this is bisected and because this has right angles. We didn't do that. What we did prove in the previous step, we proved that AD is congruent to CD. Notice how D is a point on this supposed perpendicular bisector, on this line that we want to prove is the perpendicular bisector of AC. And what we did is we proved that the distance from D to A and the distance from D to C are equal to each other. So we proved that this point on this line is equidistant from both the endpoints. We also proved in the previous step 6 that AB was congruent to BC. B is a point on the perpendicular bisector, on the supposed perpendicular bisector. And what we just proved is that from B to A is the same distance as from B to C. So what we proved here is that BE is the perpendicular bisector of AC because points along this line segment are equidistant from the endpoints A and C. And that's the definition of a perpendicular bisector. That's a more formal definition, that it is the set of all points that are equidistant from the endpoints of the line segment. I'm going to write this as best as I can. So 2 points on BE, which are B and D, are equidistant from A and C. So BE is the perpendicular bisector of AC. You just need to get the fact in there that if the points are equidistant from the endpoints of AC, then that's another way of knowing it's the perpendicular bisector. Okay, so AB is perpendicular to BC, so that means a right angle is formed where AB and BC intersect. DE is perpendicular to FE, so that means a right angle is formed where they intersect. And that's due to the fact that perpendicular lines form right angles. And then we know that they're congruent due to the fact that all right angles are congruent. They also tell us that BC is parallel to FE. And since they spread that given out, since it's not at the very beginning, that leads me to believe that the next step is going to follow from the parallel lines. And I see it's about angles, so I'm going to think about my angle relationships when parallel lines are cut by a transversal. We have BCA and we have EFD. And notice how those are alternate interior angles. So let's put that here. Alternate interior angles are congruent when parallel lines are cut by a transversal. And then they also told us in the givens that AB is congruent to DE. So here we have angle, angle, side. To prove the triangle's congruent, you could also write SAA, it's the same thing. And then we can determine, once the triangles are congruent, that AC and FD are then congruent due to CPCTC, because they're corresponding sides of the congruent triangles. Here we have our last proof, and we're actually doing a proof that we did in class when we first learned about the triangle sum theorem. And we're proving that all 3 angles of any triangle have to add up to 180 degrees. Okay, number 2 is a little bit tricky. It's asking why you're able to draw this auxiliary line, this line that's parallel through point C, parallel to AB. And I'm going to put here through any point, there exists one line parallel to the given line. And that's the parallel postulate, right? If I gave you this line and this point, and I said, draw a line parallel to this one passing through this point, there's only one you can draw. And that's what the parallel postulate says. That's what this is, the parallel postulate. Then it's telling us the measure of angle 1 equals the measure of angle ACD. Oh, and that's because they are, let's think about this for a second, they are alternate interior angles. Seems to keep coming back. And angle 3 is congruent to angle BCE. That is another pair of alternate interior angles. Alternate interior angles are congruent when parallel lines are cut by a transversal. And now it says measure of angle ACD plus angle 2 plus BCE equals 180. So if you put all of these together, it makes 180. So I'm going to put over here angles that form a linear pair or a straight angle sum to 180 degrees. So since all three of these angles added to 180, this angle up here is essentially angle 1, right? Because they're congruent alternate interior angles. This angle over here is essentially angle 3. So if this is the same 1 as over here, this is the same 3 as over here. So if we put this 1, this 2, and this 3 together, it should be the same as these equivalent angles. And that is substitution. We're replacing what we already said with things that mean the same thing. So we're replacing this angle, which was this one, with the one that's equivalent to it, with angle 1. And we're replacing this angle over here, that is angle BCE, with the one that is equivalent to it, which is angle 3. So that's substitution, replacing one thing with something that means the same thing or is equivalent.